So we can move to the second paper. The second paper presentation, for which I invite Mr. Mahesh Kulkarni, Assistant Vice President, Business Development Bioenergy, Praj Industries Limited, to make his presentation on BIOSYRUP, a game-changing sustainable feedstock enabling round-the-year operations. Sir, you have 20 minutes for presentation and 5 minutes for question and answer. Welcome, Mahesh Kulkarni.
Thanks for unmuting me. Very good afternoon, everyone. We're really thankful to Strive for giving us opportunity to today talk on the BIOSYRUP new technology. First of all, I also would like to thank Professor Narendra Mohan sir. He was at Praj, and he has given us a very excellent background on the feedstock, that is the syrup, which we are using today for the production of the ethanol to get all the benefits extended by the government policies. So going forward, I shall be talking on the three areas. First would be the business drivers and challenges for the syrup to ethanol. Second would be the BIOSYRUP technology, and third would be the BIOSYRUP benefits and applicability. Professor Narendra Mohan sir has very well briefed us about what are the various raw materials currently available in the sugar complex, which can be diverted for the ethanol production. So firstly is the primary juice, secondary juice, then third the muddy juice, or even what we call filtered juice, then the syrup, sugarcane syrup, B heavy molasses and C molasses. So all these sugary raw materials, or what I can say sugary streams, which are currently available in the sugar complex, can be very well used in the ethanol complex. With the riders very well expressed by the Professor Narendra Mohan sir, understanding the capacity and the overall economics. So all these sugary streams have different properties in terms of the total solids concentration, total inorganic solids, or what we can say non-fermentable solids, the fermentable sugars or the F-bind ratio, volatile acids, the presence of the nutrients, and ultimately the volatile acids. And most importantly, the microbial count. Perhaps most of these process developers forget about the microbial contamination and volatile acidity. As rightly mentioned by the NM sir, we are focusing on the sulfitation and defecation as the modus operandi of the sugar complex, and perhaps focusing the impact of these sugar complex on the fermentation process. But that is not the case. I will discuss in the slides forward. So let's understand what are the drivers for the sugary streams to the ethanol complex. Very much focusing on the Atmanirbhar Bharat. The driver is E20 and the beyond, what we are going to do. Doubling the farmers' revenue, attending the energy security, reducing the import of crude, and most important, reduction of the 1 billion ton greenhouse gas emissions by the 2030. So certainly the challenges faced by the sugar industry are the availability of the feedstock, surplus sugar and volatile market dynamics. Almost 6 million metric ton of surplus sugar is available, and volatility in market dynamics, very much focusing on the price of the sugar. Diverting sugar, syrup to the ethanol is very attractive if the price of the sugar is say below 32. But when the price is volatilizing between 34, 37 rupees as on date, then how the market dynamics would give a preference for the sugarcane syrup. Third most important thing, very well expressed by the sirs, higher consumption of the supplementary fuel when we are using the sugary rich raw materials in diverting to the ethanol production. Because our distillery complex has been optimized or configured based on the steam and power required by the distillery. The most important is the contamination of the syrup, which I very well expressed. Another thing more in case of syrup, unlike the B heavy molasses or the C molasses, the paint wash generation is higher if you are not recycling this paint wash back into the process. And most importantly, as rightly seen in the earlier presentation, there are different options available to run the sugar complex to produce or maximize the ethanol production. So round the year operation, and what are the options available? So if you see syrup as a feedstock, we have visited a couple of the ethanol plants which are running on the syrup to ethanol. And today we are very much focusing on the nutrients, then the fluctuations in the bricks in the feed stream. But another thing is where you have to go in depth of the feedstock analysis. We have analyzed some of the raw materials which are, or the syrup samples which are available from the north, south, and west region. And we have noted one predominant factor is, once upon a time, we used to say the volatile acids in the syrup would be in the range of 1100 to 1500, but that's not the situation. Lactic acid content, that also varies between the region to region. The most important thing is how we are operating the sugarcane mill, how we are maintaining the hygienic conditions in the milling section, how we are using the mill sanitizing agents to control the volatile acidity and to control the bacterial contamination. So we need not have to just focus on the distillery complex in context to the feedstock composition. Perhaps it's an opportunity for all of us to relook back into the sugar milling, the milling section, that how we can improve the quality of the sugarcane syrup. Some of the distillery complex in the Bihar, even we have noted that the sugarcane syrup volatile acidity is varying between 7,000 to 14,000 ppm. Even we have observed one sugar complex in the South India, which has 12,000 to 14,000 ppm of volatile acidity in the syrup. So root cause analysis is very important while considering syrup as a feedstock. It is rich in ebb-bind ratio, means higher fermentable ratio as compared to the non-fermentable sugars. Another important criteria is the free amino nitrogen. The free amino nitrogen is again coming from the sugarcane itself, but it is in the form of, say, proteins or the hydrolyzed proteins or peptides, and which can fetch some nitrogen supplementation to the yeast. But that is not the adequate as far as the yeast growth is concerned, because you know that ethanol production is very much focused on the yeast growth, and it produces more alcohol when the yeast is growing. So this is another important parameter, how we can improve the yeast growth in the fermentation. And most importantly, the total inorganics. The total inorganics reflects the presence of micronutrients. See, we are talking about the nitrogen, CNOP, as the basic ingredients for the fermentation process. But there are the other micronutrients like zinc, calcium, magnesium, to a certain extent copper also. And these micronutrients enhance the production of the alcohol as well as the growth of the yeast. Today, in case of the syrup, unlike your C molasses or B molasses, we are targeting minimum 14% to 15% V by V ethanol tighter in the fermenter. So when we are targeting higher ethanol concentration, we have to very much focus on the yeast growth kinetics and the production of the ethanol. So most important thing is the higher lactic acid, nitrogen deficiency, and micronutrient deficiency. These are the critical parameters in case of the syrup. And that results in the reduction of the alcohol concentration, higher spent wash generation, higher supplementary fuel consumption, as rightly mentioned by the sir. Then frequent corrosion in the distillation also. We have noticed in some of the syrup-based ethanol plant, there is an increase in the acidity, and that causes corrosion in the downstream operations. Extended time cycle in fermentation, again, it attracts the acidity, increase in the acidity because of the bacterial contamination, as well as the deterioration of the congeners in the fermented wash. And that ultimately we have to produce the ethanol to just blending in the gasoline. But again, the congener profile is very important, and when we are experiencing the higher fermentation time. So all these are the critical issues which have an impact on the variable cost of production. This will increase your nutrient consumption, this will increase your yeast supplementation and other things. So having experience in the operation of the many ethanol plants in India as well as in the international market, we have fingerprinted many syrup samples and other sugary samples at our Praj Matrix R&D center, and that help us in the innovation and new technology development. So coming to today's topic about the BIOSYRUP, now I shall be focusing on the BIOSYRUP technology. The problem statement here is for the round year distillery operation, can we store the syrup? Because we have seen the option in the various options mentioned by the NM sir, that we can have the different storing of the B heavy or storing of the C molasses for the round year distillery operation by diverting syrup in the crushing season. But do we have any option that we can store the syrup itself during the crushing season? So yes, for the storing of the syrup, most important challenge is the higher water content in the syrup. So that attracts the contamination, and that disallows us to store the syrup in the storage tank. So we have to remove the maximum water in the syrup. But can we do this? Because if we concentrate the syrup, there is a possibility that the sugars will crystallize and we will not be able to store the syrup. So basically, this BIOSYRUP technology is the inverted sugarcane syrup, which can be further concentrated up to 80 to 85 bricks, maximum shelf life of the cane. So here we are reducing or removing the water in the sugarcane syrup, but disallowing the crystallization of the sucrose or the sugar. So what are the various technologies available as on date to do the inversion? So acid hydrolysis is the conventional technology, and by the acid hydrolysis, because in the laboratory also we do the TRS analysis and we do the inversion by using the acid hydrolysis. So in case of the acid hydrolysis, there is a loss of sugar in the inversion process. So it demands also the neutralization if we want to use the acid as a hydrolyzing agent. So we have to add the caustic. There is a chances of the caramelization because it's a high temperature reaction, and that generates the other congeners like the furfural and the carboxymethyl cellulose and other things. So the Praj has selected the enzymatic process, which is a green technology, which ensures no loss of sugar, lower cost of inversion. It doesn't demand the neutralization like the acid hydrolysis. Being an enzymatic or a bioprocess, it always runs at the low temperature, so no chances of the caramelization, and process is very simple. So this BIOSYRUP technology, what we are doing is the sugarcane milling section. We are preparing the sugarcane juice, then it is treated chemically, liming and sulfatation, and then we go for the clarification and we produce the bricks at 55 to 60 bricks in the evaporation section. So here we are having a unit operation that is the Praj's proprietary technology, and that is invogorator. So here we are adding the enzymes, water, syrup, and it gets conditioned. The syrup gets conditioned, and basically this is the precise dosing system with the SMS facility to key users. So it is well advanced in terms of the IT information technology we have used. So that gives the advantages to the project developers. And the most important thing is we are further concentrating the processed sugarcane syrup, which is after inversion. We are further evaporating to 80 to 85 bricks, and then it goes to the storage section. So let's compare the quality of the syrup and the BIOSYRUP. So in case of the syrup at 55 bricks, the sucrose content is about 44 to 45%, and balance is fructose to glucose. In case of the inverted bricks at 55 bricks, 12 to 15% is your sucrose, and rest is glucose and fructose. And in the BIOSYRUP, we are targeting 25 to 30% of the sucrose, and balance is the glucose and fructose. So in case of the BIOSYRUP, the total solids or the bricks would be around 80 to 85 bricks, and the TRS would be 74 to 75, and fermentable sugars would be 70 to 72. Now coming to the effluent characteristics in the sugar complex in context to the feedstock, typically the C molasses, we can target 8 to 9% alcohol, but we cannot do the vinasse recycle or spent wash recycle because of the higher solid concentration as well as the volatile acids. So initial solid concentration in the effluent would be 16 to 17%, and spent wash generation would be 9 to 10 liter per liter of alcohol. And after the evaporation, it would be 2.8 to 3 liter per liter. In case of B heavy molasses, There's an opportunity to recycle this paint wash because of the higher F-band ratio. So 25% of the vinasse can be recycled back into the process, and ultimately 60% solids concentration, concentrated vinasse would be about 1.7 to 1.9 liter per liter of alcohol. In case of the juice syrup, again, because of the higher F-band ratio, and with the opportunity to recycle almost 50% of the vinasse paint wash back into the process, we can achieve almost 0.3 to 0.4 liter per liter of the concentrated vinasse. Same is the case in case of the BIOSYRUP. Here also there's an opportunity to recycle almost 50% of the vinasse, and we can achieve 0.3 to 0.4 liter per liter of the concentrated vinasse. The plants which are having the biomethanation as zero liquid discharge as a end option. So typically in this case, the COD would be 8 lakh to 9 lakh, and BOD would be 3.5 lakh to 4 lakh, and the solids concentration would be 6 to 7%. Now coming to the BIOSYRUP experience, as far as the innovation and technology commercialization, we started in 2018 with a lab scale for the BIOSYRUP. Further, we moved into the pilot plant scale trials, and in the December 20, we had a demo plant at the German Sugars, and 240 metric ton of BIOSYRUP was stored in the December 2020, and the feedstock composition was weighted by the Vasundhara Sugar Institute to see if there is any deterioration of the feedstock during the storage condition. And in the December 21, we did the fermentation of the stored BIOSYRUP. So as for the weighting or validation of the BIOSYRUP during the storage section, the observation is that there is no deterioration of the TRS during the storage, although it was inverted, means glucose fructose as well as in the syrup. So there is no deterioration of this thing. And when it was operated to produce ethanol, so typically 70% of the sugar concentration, the fermentation efficiency achieved by German Sugar was almost 92%, and the recovery was almost 425 liter per metric ton of the syrup, and the spent wash generation was about 3.3 liter per liter of alcohol. So what are the facts and figures about the BIOSYRUP? So when we are talking about the bio-inverted syrup, the preservation cost would be roughly about 78 to 80 rupees per ton of the cane crushed. Yield of ethanol is 400 to 430 liter per ton of BIOSYRUP. Spent wash generation about 2.6 to 2.7 liter per liter of ethanol. Storage can be done up to 12 months under atmospheric condition and below 40 degrees centigrade. And significantly, we have noticed that there is no loss of sugar during the 1 month storage. So when we are talking about the 1000 TCD sugarcane milling, we can produce 81,000 liter of the ethanol. So typical, if we are considering a business case of 100 KLPD distillery complex, we can have 1,250 TCD equivalent for the BIOSYRUP conversion for 160 days. And balance of the BIOSYRUP can be go into the storage section. And that's the way we can run the operation of the 2,500 TCD. Now coming to the applicability and benefits of the BIOSYRUP. Of course, it gives the off-season production of the ethanol for the sugar complex. Another applicability, sugar mills without any distillery, non-attached distillery can produce BIOSYRUP for trading as well. There's a feedstock during the no-cane situation for the distilleries operating on the syrup. Advantages of the BIOSYRUP technology are the round-the-year operation of the distillery, no external dependency for the feedstock, flexibility in operations so that we can balance between sugar production, capacity expansion for the existing distillery, again with this maximum production up to 50% with minimum investment, and low spent wash generation. Now let's see what are the industry experts speak on this. Yeah. So perhaps we are providing the end-to-end solution across the value chain, right from the feedstock, technology, engineering, plant and machinery, and the customer connect. So we can offer the entire solution for a sugarcane mill up to biorefinery. Thank you very much. Really appreciate for your service. Thank you.
Thank you, Mahesh Kulkarni ji. I think some questions are there in chat box.
Yeah, Kulkarni sir, you can access to the Q&A session, sir. Q&A.
Okay.
And sir, first of all, there is a question from Professor Narendra Mohan. That
Yes.
is, have you checked the deterioration under the conditions of subtropical region where the temperature varies from 4 to 48 degrees centigrade?
See, the observation is during the winter season what we have seen. But again, when we are doing the further studies, we will understood the more in-depth analysis of the feedstock composition.
Sir, you can open the Q&A box and you can take some of the questions, sir, from bottom, sir.
I can see a question like, what is the maximum limit of VA in the syrup which will not affect the fermentation efficiency?
Yeah.
So syrup, as I have mentioned that when we are doing the spent wash recycle, so the volatile acidity should not be more than 1500 to 2500 in the syrup. Because once we start the recycling of the spent wash back into the fermentation, even if it is at 20-25%, your volatile acidity will increase in the fermentation. And that will again contribute to the extended fermentation time. So it is not at all advised to increase the VA in the syrup. So we have to control the VA itself in the milling section. The last question I would like to address, what is the conversion cost for the BIOSYRUP? It is roughly 8 rupees per liter.
Okay, sir. Thanks a lot, sir.
Thank you, Mahesh Kulkarni,
Zoom window
for
and try to
your nice presentation.